Welcome back to another video. Welcome back, guys. So today we are doing another live stream, but due to the need for people to actually arrive, I will be sorry about that. I will be giving them some time. So we shall officially begin at 8:15 p.m., which is in about 10 minutes. Okay. And that being said, make sure that you let your peers know about this right now, so we can have this, as many people as we can for this this little event that I have. So I'm just gonna start sharing it, and we'll listen to lyrical. It's like 1 10-minute song, and then once it's over, we can begin. All right.
Popcorn! Action! Okay!
愛你，我管不了是禍，未想過是為何，能愛着你，苦也未去多。有着我，便有着你，真愛是永不死，穿過喜和悲，跨過生和死，See me fly，I'm singing in the sky， 假使我算神話，因你藏更愉快。憑我徹底的勇氣，愛是最大權利。不理場面不偉大，我共你始終同遊生死，還有那一種熱味，發光一切在乎你。沒有想過太多，我只需要你。戀愛大過天，想不想也日夜懷念，連甜夢也不夠甜，怎麼閃？同學始終會遇見。Shall we talk? Shall we talk? 就當重新手拖手去上學堂。我帶着情意，一絲絲悽藏，許多説話都仍然未講，縱隔別遙遠，懷念對方，悲傷盼換上再會期望，越問越傷心，明明無餘地再過問，明明知道衷心一吻，會有更親厚質感。說過要你快樂，讓我擔當失戀的主角，改寫了劇情，無言地漂泊。我想看，你可不可以暫時別要睡，陪着我，像最初相識。我當時未怕累，但如果說下去，或者沒有說話未曾講，你這剎那在何方？如何能聯繫上？願你再相伴再旁。如神話，寫信，這是片灰夢，心中記憶。一生照我心，我的愛如潮水，愛如潮水將我向你推，緊緊跟隨，愛如潮水，它將你我包圍。冷冷雨，沒焦點因找不到你，冷冷雨第一彷彿。經過，答應我你從此不找深夜的快慰，不要輕易嘗試放縱的滋味，你可知道這樣會讓我心碎。 聚，不忍遠離，心裏亦有淚，不願流淚，望着你。各種空虛冷冷冷，吹起吹起風裏望，過去的心火般灼熱，今天已變了冰凍。來又如風，離又如風，或世事通通不過是場夢。人在途中，人在時空，相識也許不過擦過夢中。就算你壯闊空堂，不敵天氣，兩鬢斑白都可認得你。別離沒有對錯，要早也解釋不多，現代說永遠已經很傻。隨着那一消去，火花已消逝，不可能付出一生那麼多。也許相愛很難，就難在其實雙方各有各寄望，怎麼辦？要單戀都難，受太大的禮會內疚，卻也無力歸還。Darling, I want you， 你竟不知。心中氣子，情無限次，欲話我知，卻也停止。共似天涯淪落人，再次相信這通道上同行。也許不必知道我是誰，無謂令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令你令 如何可以不愛他？莫非生命只配有一個他？到了沒法相處，再去記他好處，憑回憶製造這自欺的笑話。隨時日在遠飛，難捨棄。每次看見亮燈到訪的你，那年冬天，兩心遇上。可以笑的話不會哭，可想知的心哪怕追逐。可惜每次遇上熱愛，沒法使我感覺我終於遇上幸福。來忘掉錯對，來懷念過去。日子總有樂趣，不相信會絕望，不感覺到躊躇，在美夢裏競爭，每日拼命進取。世界將我包圍，細細都一齊，壯觀得有如懸崖的婚禮，也許身經世上，無重要作為，形容這種真愛會來得。地球天地放過一雙戀人，怕發生的永遠別發生。從來未順利遇上好景降臨，如何能重拾信心？春也久住我吧，100年去了，一個愛人都沒有，不都是可憐的，如果沒愛過，人生是黑白的。誰料我蠢得竟可重複去犯 是前度何必聽我吠？別再做情人，做隻貓，做隻狗，不做情人，做隻寵物至少可愛迷人。和你不瞅不睬，始終只會成為敵人。好心一早放開我，好心一早放開我，從頭努力也坎坷，通通不要好過。來年歲月那麼多，為繼續而繼續，沒有好處還是我，若注定有一點苦楚，不如自己親手割破。誰得到過，願放手，曾精彩過，願挽留，年年月逝去，越是覺得深愛你。
Alrighty. Alright, time is up. For those who are not here yet, oh, I'm gonna just say, good to you guys. Anyways, so, alright. So, yes, this is the same exact, exact same slides that I used for the, what was it? Oh, let me choose that for the pointer. Yeah, there we go. So this is the exact one. Is this on? Hold on, I can't tell. Is the pointer working? Hold on. It doesn't seem to show up. Testing. Okay, was the music playing? Hold on, I'm curious now. Well, that might be my my phone actually. I have my phone on. Okay. Okay, so I have my phone. Alright, so just so you know, I have my phone on just to make sure that everything's running nice and smooth. To make sure that what I see on my screen should be what you guys are seeing on your screen. Though I don't see the pointer, unless the pointer doesn't work. Okay. Hold on, let me get rid of that. Okay, there we go. Close that. Okay, there we go. Okay, now I should keep just make sure everything's monitored. Okay. Do you guys see this? Does that work? Did that work? Oh, come on. Oh, this is extreme lag. Okay. There's about 10-second lag between what I do and what you guys see. Okay? Alright. Just wanted to make sure that's working. So, scroll down. So, I can go over all this stuff again. But I haven't changed it. I haven't had the time to change it. I was mostly focused on doing the optimization stuff. So, here we go. So, first one is, what is optimization? And to put basically, optimization is the process of taking the given constraint and set of values you have and make them as big or as small as possible. So like, these are just two quick examples I put down. So if you have a certain amount of money, right? You want to spend the least amount of money you can, but make the largest box, right? And the volume is 200 cubic units. Well, I think I messed it up. Sorry, that was supposed to be the total length is 200 units. My bad. But the largest, and then the other one's the largest area for a kite with a perimeter of 50 square inches. That's what it's supposed to look like. This one, it should have been the largest box with the smallest, spending the least amount of money, and it had, actually, hold on. No, I think that's right. That's right. I'm pretty sure that's right. No. Okay, alright, next one. Steps for optimization. So the first step is to figure out the two equations. You have the constraint equation and the objective. You have the constraint and the objective. And so the constraint equation is the one where you have the given information. And the objective one, and the objective variable, that equation is the equation that you want to try and get to. So like if we go back, right here, like your constraint would be the perimeter of a kite, and your your objective variable would be the area of the kite. So like you are given this right here, the 50 square inches. That should be 50 inches. My bad. Okay, that's supposed to be 50 inches. So your constraint would be 50 inches for the perimeter, that's your constraint. And your objective variable is the largest area you can have for the kite with that constraint of the perimeter. And that's the whole general idea. You know, you have your constraint is what is restricting you, of course. And what's restricting you is the limited perimeter that you have. Next one is to solve for one of the two variables of the constraint equation. So generally you'll be given two variables. If it was a rectangle, it would be length and width. If it was volume, generally they'll give like the length and the width as the same type of variable. Like in one of the questions I did, it's like the length and the width. It was like you have the width, which is x, and the length, which is 3 times the length of the width, which makes it 3x. No, if like the width is x, that means the length would be 3x because it's 3 times longer. And that would instead of making it 3 variables, instead the problem cuts it down to 2. And the other thing to take into account is, you know, which one is easier for you. You know, it doesn't matter which one you start with as long as you're able to figure it out. So continuing forth, this is the reason why I'm talking about this, is that when you get the derivative for the objective variable, trust me, it might seem weird now, but once we go through this whole the whole process, I hope that you understand a bit better. But when we take the derivative of the objective variable, it's much easier to do that without the fraction. Yes, you can do that by doing the whole negative, you know, let's say you have 1 over x, right? You can do 1 times x to the negative 1 power. That can work, you know what I mean? But if you just have like a regular, you know, without all the fractions, it makes it a lot easier. Like if you have, you know, x squared plus 10, that's much easier to find the derivative of than anything with a fraction. I can pull up something like 300 over, you know, x to the third and times the square root of 10, something like that. You know what I mean? It's gonna be much easier if without the whole fraction stuff. Yes, you can do the quotient rule, but you know that takes time. So it like I said, whichever floats your boat. So the next part is to equal the objective variable to 0 and solve for x. So once you find the first variable, then you plug it back in to the constraint equation. So a rectangle, right? Let's say you find the length of the rectangle. Then you plug back in the length with the constraint equation of the area. So let's say the area is 50, right? And your length is 10. Then you plug in the 10 for your length, and you already know the constraint value, which is 50. And then you solve for the width, or w. And then, you know, you do the whole thing. You get 5 for your width. Then once you find that, you plug in. You get the other variable, which like I said, you find the length, then you find the width, and then afterwards you find the derivative of the objective variable once you do all that stuff. And then once that is done, you take the derivative and you equal to 0, and that's when you find the second variable. Yes, it sounded a bit. It's like I said, me explaining it this way sounds really weird. But once we get into the problems, I think you'll understand it just a little bit better. You know what I mean? And then the last part is to plug in the first and second variables to find the answer desired in the objective variable. So like I said, going back to this one right here, the second one, you have the kite, right? You find all your variables, and then by the end you should be able to find the area of the kite. So I believe it's the next one, right? So I found a perfect photo for this. So this is the question, right? A pizza chef was asked to make the biggest pizza possible for his last group of customers, and only has 150 square centimeters of dough left. What are the dimensions that can give him the largest Sicilian-style pizza? I feel like the photo puts it pretty well about what you have to do. Yes? So first thing is take note of what the question's asking, right? So you have 150 square centimeters of dough left, right? This is all you got. And you have to make the largest pizza you can with that amount of dough you have. Okay, this is lagging really bad, but that's fine, right? You have 100 square centimeters of dough left, and with that 150 square centimeters of dough, you have to make as big of a pizza as you can. Now, yes, it should be a pizza pie, but due to the fact you need two variables, we have to do a Sicilian style pizza in a rectangle. I mean, that's the best way to put it. And I made the question myself, so let's not get too complicated when I can mess up easy enough already. So, alright, let me just pull up my whiteboard. Hold on. Okay, so turn that on, turn this off. So, Mr. Whiteboard, right? Clear the whiteboard. Hold on, let me change the color. Why is it all black now? It was fine earlier. What the? Okay. I'll use white then. So, okay. Let me just close that. Okay. So, we have 150 square centimeters of pizza dough, right? And this right here is your area. Yes, that makes sense, right? 150 square centimeters. This is your area. This is all the dough you have left, and your customers ask for you to make the largest pizza you can. Of course, perimeter. Because the bigger the pizza, the larger your perimeter will be. Alright, so of course your perimeter is length times width. And so you plug it, and your area wait. Do not say anything. I figured out what happened. Okay. Okay. Let me just forget this happened. Okay, I don't have a proper eraser. Okay. I know what I figured out what I said. I messed it up already. I'm already messing up, and we're only like 5 minutes in. Not even, maybe. Okay. Okay. So back to the white color. Okay. So you have your perimeter, right? Which is 2W plus 2L. Right? This is the equation for perimeter. And your area equals length times width. Now these right here are your two equations. Because you know your area already, this is what is called the constraint equation. Because this is the equation that has the constraint of 150 square centimeters. The constraint is, in this case, the largest amount of pizza you can make. The largest area your pizza can have. Hold on. I think my thing is bugging. My calculus video is bugging a bit. Oh no, okay, we're good. It's just my phone. I'm good. So, oh, someone's here. If you are watching, oops, hold on. Hold on. Don't forget, whoever's watching right now, comment down below your initials. I want to know, I'm really curious who actually came to show up. So, like I said, this is your area, which is the length and width, and this is what's called the constraint variable, the constraint equation. And the reason why is because, well, this is the restriction right here. Your pizza cannot be larger than 150 square centimeters. And this is where, and this is how you start, alright? And now you can choose between L or W. It doesn't really matter. In this case, it doesn't matter, because either way, you're going to end up with a fraction. You can choose either one, right? The way I did it, I chose to find W. So I divided on both sides L. And then you get W equals 150 divided by L. Right? Make sense? Hope that makes sense. You take 150 divided by L. This is the what you get for your width. So, one second. Okay, so okay, okay, I'm sorry. Okay, so my friend suggested that I do Minecraft relate calculus. Okay. I just want to say, maybe in the future if I understand it better, but right now, no. Okay, back to this. Okay, no more distractions. So like I said, this is your width. You have 150 divided by L, right? Your length. Wherever your length is, you're gonna take the 150 and divide it by that. And now you plug in your W back into your into this equation, right? If you guys remember, hold on. Let me just go into the page. This. Oh no, hold on. I just want to make sure that I have the slide for myself to make sure that I have the numbers correct. So you have the objective what's it? Hold on. The objective variable, right? Which is oh frick. Okay, there we go. So this right here, your the perimeter stuff, the equation for your perimeter, that is what's called the objective variable equation. And this is all based, and this equation right here, your perimeter, is based off of what you have for your area. If you change your number for area, this is going to change your perimeter, right? We can do this. The same exact problem with a different amount after this, just so I can show you that. So you have your perimeter, and now you plug in W. Easy enough. Equals 2, and then plug in your W, which is 150 divided by L. Oops. There we go. It still looks like an L. Yeah, kinda. And then you add 2L. Boom. Like that. Alright, so next thing. I'm sorry for the whole, the misleading thumbnail. I am not really able to change it on this until after I make the whole video. I mean, I could have done it a bit earlier, but I was still making some preparations. But back to this, right? This is your perimeter. Excuse me. Next thing is just simplify it. Kind of obvious. Take your perimeter, equal it to 300. No, I heard something downstairs. 300 divided by L plus 2L. Right? That is your thing. There you go. Plus 2L. That right there is your perimeter. And now that you have this, right? This is the next step, right? So we have, hold on, let me just go back to this. So we have step 1. Oh, excuse me. So step 1 is right here. You figured out what your two equations are. You have your constraint equation, which is your area, and you have your objective variable equation, which is your perimeter, right? That makes good sense, right? Then you solve for one of the variables, which we did right here. We solved for W, and for W we got 150 divided by L, and then we plugged it back into, and we put, well, not back in, but we plugged it into the objective variable equation right here, which is the perimeter, and we got 300 over L plus 2 times L. Yes. Next thing is a very important part. I personally have an issue forgetting to do this part, which is to take the derivative of the objective variable equation. So now we take P prime P. So we take the right here. We have the derivative of P. First is simplify this, right? You can always do this with the L and the 300, right? Yes, we all agree on that. You get 0, then 1. This is 1, this is 0, right? But an easier way I think is to do this is you just break it down like that. So we have 300 times L to the negative 1. That I feel would be a bit easier to do. So you have 300 L to the negative 1, right? Or times L. It's the same thing, right? So then you take the derivative of this right here, and your negative 1, you bring down the negative 1, 300, and since it's 300, this is negative, nah, that's fine. So negative 300 times L to the negative 2 plus 2L. Now, because, hold on, let me check. Okay. Oh. So we got one person on. So I'll give you 1 minute, right? To so at 8:39, I will delete all of this. I'll delete all of this out, and we will continue on. Just just so I can give you a moment to copy it. I'll give you 1 minute. All right. Oh, nice. Welcome everyone who came to watch. Thank you very much. It's appreciate that people came. So, I think that should be enough time. If you need to, you can pause the video, or you can just wait till after the live stream is over to copy all of this. And another thing that I will do, here. So, oops. Okay, so this right here. Let me just go back. So remember what we did, right? We figured out the two equations, which were the area and the perimeter. We found the area, which is L times length times width, and you have the perimeter, which is 2L plus 2W. Then we found one of the variables, which you chose to find W, and in doing so, we found that W is equal to 150 divided by 150 divided by L. Excuse me. And now we just took the derivative, right? Right here, we took the derivative. We took the derivative, which is right here, negative 300 times L to the negative 2 plus 2L. But you can also rewrite it this way: P prime equal, I believe it's prime. If it isn't, let me know. If I say prime by accident, it shouldn't be, my bad. But you can rewrite it like this as well. This is totally legal, actually. You can do this. So you have the negative 300 over over L squared plus 2L. Next thing, right? If you guys remember, right here. So, and now we found the derivative. Next thing is we're going to equal it to the derivative equaling to 0 and solve for our variable. Usually, majority of the time it will be x, but in this case it is L. So I think that should be enough time in order to, you know, get what is happening here. So I'm going to erase all of this, clear the whiteboard, and so the next thing is P prime equals negative 300 divided by L squared plus 2L. Boom. Alright. And to equal that to 0. And like so. Oh, I'm gotten better actually at writing. There we go. And that is what you should get for your equal to 0. And then you start finding the equation, right? Try and solve for L. So then I would take this right here, subtract it to the left. Actually, let me. It's too late. All right. So I don't know why, but I don't have an eraser. It's kind of weird. Oh, actually, hold on. Save current drawing. Escape whiteboard. Clear whiteboard. Shift. Okay, yeah. So I don't see a button that can do that, so it's fine. And divide this by L squared. This makes this side positive now instead of negative. Equal it to 2L. Now the biggest thing, especially with doing optimization in this case, right? In this case, for things like area, length, perimeter, per volume, and all that, make sure your stuff is positive, right? Make sure it's positive. So then you do this. You have this equation right here, and then you subtract. Okay, that's a bit off. But you multiply it on both sides. L squared. Hold on, right? Oh, hold on. Wait. Hold up. Oh wait, hold on. My bad. I forgot one big thing. Right? When you have, this is your P, right? You have, oh my god. Okay. I messed up. Oh boy, I messed up. Really bad. So, this is your P, right? P equals, what was it? 300L over 300 over L, right? Plus 2L. I forgot this. I'm glad I caught it. So yes, I'm pretty sure someone was like, "Oh my God, you freaking idiot!" When you do this, right? When you find the derivative, you get this, right? You get the negative 300 over L squared. But also you drop this, so like that is taken out. So then you just get plus 2. Okay? You get plus 2. Got that? Plus 2. So back to this, you have the 0 equals negative 300 divided by L squared plus 2. Okay? And then we take this, add it on this side, 300 over L squared equals to 2. Then you multiply both sides L squared, so like multiply L squared times L squared, right? Do this, because you have to find L, you gotta put it all into one side. And you get 300 equals to 2L squared. Then you subtract 2 on both sides. L squared equals 180. 150. Now, if you guys want, take out your calculators, figure out what is the square root of 150. Because you do this, do that, and then you get L equals square root of 150. So I'll give you a minute, and as you do that, I will be writing out what the answer for L is. And you should have gotten, right? I think that was adequate time to figure out the square root of 150. Your L should have been 12.247. It's a remember, write out the whole thing. Don't forget it. Write out the whole thing. 247 4 4 8 1. There you go. And that should be your L. Okay. I hope that makes sense. Alright? I really do. Now, next thing, right? Next thing is, so now you have your L, right? You have your L, and you want to know what your W is, right? So actually, you know what? I'll give you a minute. Copy this down, right? If you remember our steps, this is what we did. We solve for the second variable, right? This is what we're gonna do. Step 6. We just did step 5. We equaled the objective variable derivative to 0, and we solved for the x that we wanted, or in this case, our L right here, or this specifically. You know, it's the same exact thing. I'm gonna write out the 150, the square root of 150, for the sake of time, but also the sake of my hand, and that I can fit it on the screen. Because if I put this everywhere, it's gonna take up space easily. You know, I don't have the smallest in terms of handwriting on the computer, let alone real life. So now that you guys, you know, if you guys need to, just, you know, come back to it, look at it again. We can, you know, you can just pause the video, but I will move on. Oh, excuse me. Okay, so next thing, right? You have your yeah. Alright, hold on. Let me just go back to the other one. Okay, here we go. So we did steps 1 to 5 already. Next, we're gonna solve for the second. We're gonna solve for the second variable. Okay. So we go back, and so you have your same equation, right? Well, I'm just my hand. Oh yeah. Okay. Alright, we're good. I think I'm good. Alright, so next thing. Hold on. Let me just think. Where did I put it? Okay. So if you guys remember from earlier, we had this right here, right? We had the A equals 150, right? And A equals L times W, and our equation was W equals L. Oh, hold on. It should have been 150 divided by L, not L over divide. Let me just scratch that out with the black. This isn't an eraser, just saying. That is, that's the black color. So now you have your W, right? You did this again. We had the 150 equals LW, and we solved for W, and W we got this 150 divided by 150 divided by L. Okay. And alright, yeah, I know it should be. Hold on, let me just rewrite that on this right here. 150 divided by L, right? This is what we got for our W at the start, and this is where you plug in your L. And if you remember, we had L as the square root of 150. So now you plug in W, right? W is equal to 150 divided by our L, which is the square root of 150. Not regular 150, okay? This is the square root of 150. 150 divided by 150 is 1. Yeah, I know they don't have an eraser, sadly. The issue, I don't know why, but like it's just I basically just using a black marker and swiping it over. So if you guys use your calculators quickly, you can find this right here, 150 divided by the square root of 150, and you should get the same answer as we did before for L. This yes is 150, but we also got, but it at the same time it also 12.247 44871, right? Hold on. Oh yeah, no. Okay, yep. There we go. 12.247 Okay. And this is also the same number as we got for W, which is 150 divided by the square root of 150, which is 12, which is the same number, 12.247 44871, which is the same exact thing. And since it is the same exact thing, this also means it too is equal to the square root of 150. Okay? I hope that makes a lot of sense to you. Because if you think about it, excuse me, if you multiply these two together, right, it's no different than the square root of 150 times the square root of 150, or a simplified term, the square root of 150 squared. Right? Try it. You can try it. I'll wait. You take the answer they got, the 150 divided by square root of 150, right? You find it, which is this right here, over this one, same thing, it's the same numbers, and then you just square root it, and you're gonna get 150. Anyways, so I hope that so this is that part right here. Don't worry about this. This you don't have to worry about, okay? This is just a little thing to be like, ooh, it's kind of like an ooh, because this will make a bit more sense later, but it's not 100% necessary, okay? So yes, so I'm just gonna, this is where you can pause here, take a take a screenshot or pause the video, and then get your notes in. Oh, excuse me. But that's that's the whole idea right there. And the next thing, right? I'm gonna erase this. Boom. So the next thing is now you have to find the actual perimeter. So this is our perimeter right here. We have equals to 2L plus 2W, and our L, the length of the Sicilian pizza. I'll just redo, that's fine. Yeah, I just started it, so it's okay. So we just do this, 2 times the length, 2 lengths plus 2 widths, right? So the length of our Sicilian pizza is the square root of 150, or 12.247444871, and our width is also the square root of 150, or 12.247444871. And now you just plug it in. So P equals 2 times 150. And this is why I find it a bit easier when doing this, this sort of style, because it saves your time when you're trying to write it on the calculator. This right here takes no more than 5 keys. Second, x, and then you click the square root button at x squared. Then you type in 150, enter. Second, x squared, right, which brings up the square root. That's 2 buttons, 150, 150, considering you didn't mess up. Enter, 6 buttons, right? Type in that whole list of numbers of the digits, the total 0.247448871. That in and of itself is already 11 digits. You're spending time typing those out. Yes, in some cases it would be a bit easier, in order to not get distracted with the parentheses and all that. But in this case, it's very simple. So doing this will save you more time. And at the same time, it will still remain accurate. And then just like that, since they're the same exact thing. And then when you get your answer, right, which is 2 times 150 plus 2 times 150, the square root of 150, you should get this right here. Yeah, perimeter equals 48.9897486, right? Centimeters, because that was the I gave the units. I gave squared centimeters, so in this case the perimeter would be centimeters, and this should be your answer right here. 48.98979486 centimeters. Now if we go back to right here, so we did step 1. We figured out the 2 equations, the constraint, which was the area, because we were given the area, and the objective variable, which we are also given, which is the perimeter. And then we solve for one of the 2 variables inside the constraint equation, mainly because we had some numbers to work with. And so we took the 150, equaled it to the length times the width, and then we found the width, which was 150 divided by the length, wherever the length was. Then we plugged in that answer and put it into the objective variable equation, which we plugged in h with the equation that we got from the constraint equation, and we plugged it in. So we went from p, and actually I think it's fine if we did it verbally. So we went from p, because you wrote, because we went from p, right, the perimeter equals the 2 times the length plus 2 times the width, and we plugged in the width for 150 divided by L, and that's how we found. And then from there, we took the derivative of the objective variable equation, and once we did that, we got negative 300 divided by x squared plus 2, and then we equal that to 0. Solve for x, and our x in this case would be the length, or L, the way I wrote it. You can use whatever variable you want as long as you know, and you can differentiate. In this case we used L, and for L we equal that ended up becoming the square root of 150, or 12.247448871. Then afterwards you take this and then go back to the original to the first variables in step 2 when you solve for one of the variables in the constraint equation. In this case, that was h equaling to 150 divided by the length. And since we found the length, which was the square root of 150, we just plugged that in, and h was equal to 150 divided by the square root of 150, which also gave the same number, the square root of 150, which was 12.247448871. And then now that we had both variables, the length and the width, we equal that to the objective variable equation, which was the perimeter, P equals 2 times the length plus 2 times the width. And then when you plugged it in, it would be, the perimeter equaling to 2 times the square root of 150 plus 2 times the square root of 150. And as a result, our answer was 48.98979,486 centimeters. Crazy, huh? How long did we spend on that? Half an hour to explain it? Don't worry. It took me 3 hours to set this up. So, don't worry. I spent quite a bit of time on this to make sure that, it worked out. So, this is our answer right here. And in conclusion for this right here, right? This little girl has a Sicilian pizza that has a perimeter of almost 49 inches. That's a big 49 inches, right? If that's your alright, now you might alright, so quick question, right? This is you don't have to think too much about it, right? But if your Sicilian pizza, right, is 49 is like almost approximately, right, 49 inches, which in this case it's specifically it's 48.98979,486 centimeters, right? If that is your perimeter, and then you decide to draw a circle around that, what is the length of the pizza? You might think I'm crazy, right? You might think I'm crazy. So let me just pull up the whiteboard again. So let me just clear that, right? So you have your pizza. Here's your pizza, right? Hold on, I messed it up. This is your pizza actually, because it's Sicilian style. It's a square pizza because it's equal in length, it's equal in its length and width. Then imagine you just drew a circle around that, right? 9% accurate. But what is your radius? What's your radius for that? This is getting into another question that we have. It's very similar to here's the thing. I didn't practice much on it, okay? But it's really relative to the question, so I just wanted to bring it up, just to get you thinking for that question. For my classmates, right? That would be number 60 on our packet. But this time, right? The length and the width. This right here is square root of 150. This right here is also the square root of 150. They're all the same thing, right? I'll give you 2 minutes to think, okay? As I calculate it, because I just came up with this on the fly. Okay, so I got my answer. So whoever's watching right now, what do you think your answer is for this question? The square root of 150. I mean, not that. I mean, what the radius is for this pizza. If you drew hypothetically, I just had to draw a circle around it, just to be curious about how wide you know, how big the pizza is. This is this guy's first time making you know, this big a pizza. I mean, come on now. Who makes this big of a pizza? Let's be honest. Now imagine this is a square, okay? Who made such a big pizza? That was a ceiling style. And decided what would be the whole you know how the pizza pies are. They do it by the I believe the diameter. Right? It's either diameter or radius, but I'm just gonna go for radius just because it could, you know, just think about it a little bit more than if it was a diameter. In my personal opinion, at least. So, good. Okay. So my answer, right, was 8.6. So for the radius, I got 8.660254038. That is the radius I got. Now why, or actually how? Let's see. So hold on. So let's see. So we got an answer. So I'm not in your calc class, nor do I take calc, but could I guess that you find the length that well, yes, it is technically actually, yeah, it is technically the right answer. So 150 squared to the negative 2. 150 squared. I mean that's close. So the way you do this, right? I mean, if to find the radius for this, you just find the diameter. Boom. Right? Triangle. Right triangle. Hold on. 150. Special right triangle. 45, 45, 90. Yeah. You see it? And then so this would be whoever, you know, this right here. 150 squared plus 150 squared equals c squared. Now that's the diameter, right? Your diameter, which in this case is your hypotenuse, right? For this for the square, should be 17.32050808. There we go. That should be your, or to simplify it, square root of 300. Basically, yeah, same thing. I'm not 100% sure. I don't know how to read that. I think you roll 150 squared to the negative 2, it seems like. But when you put it to the negative, right? Hold on, here. That's a good question. So, you know, so you can pause the video right here and take the screenshot of this, you know, for number 60 on the calculus packet that my class has. And hold on, so just clear this, right? So, so you have 100. So this is what you have, right? You said 150, like this, right? 150 to the negative 2, raised to the negative 2, which would be 150 to the negative 2 power. Now, so that's not 100% sure. That's not exactly correct, because at least this right here, the 150 to negative 2, that would, in order to get rid of the negative, you know, you can't really keep the negative 2 up there. So, if you're not in calculus, don't keep the negative 2 up there. So, in order to get rid of the negative 2, you take the I believe it's called reciprocal, which this is what 150 to the negative 2 power would be, which is 1 over 150 squared. Yeah, I understand what you're trying to do, but that's it's, I mean, you get the idea of it. It's just that your process is just wrong, you know. So this is what 150 to the negative 2 power is, which is 1 over 150 squared. I do not have the proof for that, but I'm pretty sure there is a proof somewhere out there that can explain how that works and why. So so you don't. I mean, some of it's, you don't have to think too much of it. You know what I mean? So you have your 150 squared right here, and you have the same thing on the bottom right here, right? Same exact thing. And all to do then is just, use a squared plus b squared equals c squared, and then you'll find your hypotenuse, which in this case, when you have your square inside and the circle, it's the hypotenuse, which is the same thing as the diameter, and then divide, and you get the second half, right, which you divide by 2 to get the radius. So the next one, right? So I understand if you're not in calculus, that's fine. It's good to watch, but you can try if you want. You know what I mean? There's nothing wrong with it. So that's just so that's my walkthrough of it. So here's the next one, right? I put a meme with it too. Tech support. I'd like to report a farm in the Dell. So yeah, that's a meme. Don't worry about the meme. That's just a little something to fill up the space. So a farmer wants to create a rectangular field along the river. He has 400 feet of fence and does not need fencing along the river. What are the dimensions of the field that will give him the largest area? So you have a field on the river, right? And you're given 400 feet of fence, okay? 400 feet. And it's asking you, what are the dimensions of the field that'll give him the largest area? So I hope that gives you good hints on exactly what to find, right? So back to the blackboard, the whiteboard actually. Well, technically it's a blackboard now. So you're given 400 feet of fencing, right? And you have a river, and that's a bad river, but it's okay. And you need a fence here, and you want to use 400 feet to get the most area out of it, right? Out of the 400 feet of fences. And so, to put it simply, this right here is your perimeter, okay? Your 400 feet, that's your perimeter. That's your constraint, all right? That's your constraint equation. So your perimeter, don't forget this right here. You don't need this side of the length, okay? That's the big thing. So it'd be W, W, and L. So 2W plus L. And since this is the constraint, right? Constraint. Yeah, okay. Constraint, right? This is your constraint. And so that means you can plug in 400 in to 2W plus L. And like I said earlier, it would be generally easier for you to do this without having to deal with fractions. So L, subtract 2, subtract 2W on both sides, and you get L equals 400 minus 2W. Boom. And that being said, this right here, all right, you have, this is your equation for L. And since it's asking, right, if you go back, it's asking for the largest area. So then you would take, so then what is the area, right? Area is same as always, length times width. Doesn't matter, even if this right here doesn't exist, we still have to have, we still have to use the same equation, okay? And so then you plug in your L, right? Get A equal, and what is your L again? Your L right here is this thing right here. Remember the one we talked about here? The objective variable equation, okay? Don't forget it. Those are the best ways to think about it. Is to remember which is which. The constraint variable is the one with the given numbers, in this case the perimeter, and the objective variable equation is the one without it. You have three different variables. You have your, in this case, the area, the length, and the width. And now it's gonna be cut down to 2 because we plug in L with 400. That was horrible, but okay. 400W minus. Oh, actually, hold on. I'm skipping a step. My bad. A equal. Oh yeah, it looks horrible. Okay, so A equals 400 minus 2W times W. Then you distribute the W, and you get A equals 400W minus 400W minus 2W squared. Okay, makes sense. Now I'm gonna give a moment right here. You can pause the video, take a screenshot, whatever, or come back again, and clear. So you have your area 400W minus 2W squared. Okay. Now the reason why the problems are kind of easy is just to help you grasp the idea. If you want, if some classmates come on and they want to talk about some of the questions we have, we can go over them. If not, that's fine. It's getting late anyways. It's 9:17, so maybe by 9:30 you can end it, and then you can go about your way and finish whatever you had to do. Now hold on, let me just make sure. Well, let me. I'll be honest. I'm curious where everyone is. I sent a link to everyone. Alright, so yeah, I think the reason why it says 2 is just include myself, I think. I'm just oh, okay. So back to this, right? Sorry about that. I know it's not as professional as it could be, but yeah. So we have the area. This right here is the objective, right? The objective. I see. Even I forget. The objective variable equation. Okay. So this is your objective variable equation, and this is the one where you do the whole the derivative stuff, right? So now you found this, so now you found this, right? And we're gonna go back to the steps. Step number. So we did step 1. We figured out what the two equations were. Then we solved for one of the variables in the constraint equation. In this case, that was we solved for L, and then now we only have W. Next thing, you plug in the answer found in step 2 into the objective variable, and we end up with 4W minus 2W squared because we replaced L. Next is step 5. We figure out the variable. Okay. Take the derivative. My bad. Yeah. See. Yeah. This is why I need practice. I need practice on this bad. So take the derivative. 400 drop times 1 because of W minus drop down to 2 for W, and the whole minus 1. So then that becomes A prime. So A prime equals 400 equals 4W. Right? Now, next step, if you guys remember, solve for 0 of the variable derivative, which is still the same one we're using. Equal to 0, and you get 400 minus 4W, right? And then you get 4W equals 400. That's bad. It's okay. So therefore, W equals 100 feet. Okay? Make sense? I hope that makes sense. So then, if you guys remember, I don't have it written down. I hope, pretty sure you guys have it written down. But, okay, so, this is, save this, okay? If you need it, save it. And I'm gonna clear. So, if you guys remember what we had for L, I just gotta do it again because I didn't have it. Let me just go back to the thing. So 400 feet of fence, and we have the area. So 400 feet of fence. That's the area equal to length times width. Actually, hold on. No. No, my bad. 400 feet. That's our perimeter. So equal it to 2W plus 2L. So that was out. So then, and then hold on, let me note this down. W equals 100, right? And so we have this 400. Oh wait, hold on. No, that minus 2W equals L. I messed it up. I should have crossed out the 2. It should be, remember, because we are missing one length of the river. We're missing one length because of the river. Like that. And then you should get this right here. That is what we found for L, which is how we do step 5 right here, which we solve for X, and then now we solve for the second variable, and our second variable is L, right? And our W is 100. So then you plug in 400 equals 2 times 100. I'm going too fast. My bad. Equals to L. Then you have 400 minus 200 equals to L. Therefore, L equals to 200. Yes? Hope that makes sense. Right? Makes sense. So, and then, there we go. Deleting in 3, 2, 1. So our W, we have 100. And then our length, we have 200. Now, if you remember back in the question, got a river. And he wants a fence for an area here. And we don't care for this side because he doesn't need a fence on the riverbank. And you have W, and length. Now you just gotta find the perimeter. Perimeter in this case is, as you recall, length plus 2W. Then you just plug it in. Now just to make sure, 200 plus 2, and then 2 times 100, and this is your P, which is 400. Now that you know that this confirms that what we have is, it is true. This right here equals to the perimeter here. And that being said, nope. Oh, the 100. Oh, so yeah. So the 100 is how we got it in the earlier steps. So when you got the hold on, let me just clear this, right? So I'll go over that. It's okay. So this is our equation, right? So actually we can go over it. Let me just go back. Make sure I have the numbers. Okay, so 400 feet of fence, right? So you had the 400 feet of fence, which is the same as the perimeter, right? Your perimeter, because of the river, is equal to L plus 2W, because you're missing the other length on the river. Then you found your length, which was equal to 400 minus 2W. Then you plugged it into your area, which is length times width, right? Your length. You plugged this in for your length, which was 400 minus 2W times W. And then you got your area as equal to 400W minus 2w squared. Okay, this is and then afterwards you take the derivative, which you drop the w because this is times, because when you do the derivative, okay, so you have your 400, this is your constant, you keep your constant, which is 400, and then for your w, right, w is the same as having w to the first power, and when you take a derivative, you put your 1 to the front of it, so then it would become 1 times w, right, and then your exponent 1 minus 1, which in this case which would equal to 0. W to the 0 power is equal to 1. So so in most cases, right, you can basically just drop the w because it's going to be times 1. 400 times 1 is 400 still. And then same for the 2 right here, the negative 2w squared. So you still have the subtraction, and you have 2w squared. Bring that to the front, right? This is a constant, so you keep that. 2 times 2 is 4. Bring down your w because 2 minus 1 is equal to 1. So this is 4 times w to the first power, and that equals to 4w. Does that make sense? I hope that makes sense. Don't worry, you don't have calc this year, but you might have calc next year. You know what I'm saying? So good to at least get a general understanding of the derivatives now, because that's, I feel, was a pretty hefty topic in a way, right? Especially some of the stuff like sine. So this is what you should get. This is your derivative after. You have your area, which equal to 400w minus 2w squared. Then you take the derivatives of each number. You have 400w, which becomes 400 because the w, when you take its derivative, equals w to the 0 or 1, which you can just drop. You can leave that. And then you have your 2w squared, which become, you bring the 2 down, multiply the 2 with the 2, makes it 4. Bring down and then you take the 2 minus 1, which equals to 1. And that's where you get your w to the first power, which is that. Okay. Next thing is, you remember that equation, right? Your a prime, or a prime is the derivative, equals to 400 minus 4w 4w. My bad. Forget about that. Just 4w, right? Then in this case, you'd equal to 0. So 400 minus 4w, and then you add 4 on both sides to find w, and then you get 4w. Yeah, my computer is lagging a bit, so my mouse clicks aren't registering fully. So then you have your 4w, and then you divide by 4 on both sides, and then w is equal to 100. That makes sense now, right? Good. 400. Boom. That's where you get your w. Then you plugged it back in, which to the equation which we had earlier. L equals 400 minus 2w. W becomes 100, and then you get L equals 200, because 400 minus 200 is equal to 200, right? So deleting in 3, 2, 1. So yes, now we know that our length is equal to 200 and our width equals to 100. Okay, and we made sure that the perimeter actually equals to 400, right? But you gotta make sure what the question is asking for. In the problem, it's asking for what dimensions will give in the largest area of field. So that's where we go back to the area equation, which was length times width. And this is the easiest part. A equals 100 times 200. And then that should get your answer, which should be 20,000 square feet. So the answer for this problem, right, is equal to yep, 20,000. Yep. Just fix that. Okay. Boom, 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 boom. Okay. Which equal to 20,000. What's it? Good number. Square feet. There we go. So your A equals to 20,000 square feet. And that's the answer for this problem. What are the dimensions of the field that will give the farmer the largest area? The dimensions for the length are 200 feet, the width is 100 feet, and it gave a total of 20,000 square feet. And there you have it. That's how you found, that's the river and fence problem. Now the next one is slightly different, okay? Now we're going to do it in reverse. We have a given amount of square feet, and now we have to find the dimensions of the fencing. So instead of finding the most amount of square feet of the most area, now we're going to find the least amount of fencing required for a given area. And yes, another farming meme. Riding lawnmower, $1,500. Riding mower for sale. Mows the tall grass with ease. Doesn't need gas. Has a fertilizer attached to the rear. So, that being said, we shall go back to the whiteboard. Actually, I think this color is fine. So, we have 6,000. So our area. This is our remember constraint and the objective variable. So this is our constraint. 6,000 square feet. And this is our constraint, because the area is length times width. Now remember, we are still on the same exact farm, but this time he needs a certain amount of square feet and wants to use the least amount of fencing. And on top of that, we have a river again, which that river does not need. Which if it doesn't explicitly, unless it says it explicitly, assume that you're gonna need a regular one. But in this case, it's the same farmer as this one, right? You do not need fencing along the river, as we had in that problem. Also is in this problem as well. I just didn't explicitly say it. Yes, I found some good memes. The memes I found are a bit more appropriate in this version than the original draft I had. So, yes. Kid friendliness. So, this is our area. And we need to know the least amount of fencing we need. So we have 2W plus L. And again, so this is our constraint. The constraint equation, which is the area. Equal that to 6,000. So we have 6,000 equals to the length times the width. And so same process again. We pick which one we want. I'm going to divide it by the length. Okay. And so our width is equal to 6,000 divided by the length. And if we go back, right, let's see, this says for optimization, you have your constraint equation, which is in this case is our area, right? The area is 6,000. This is why it's a constraint. It's the constraint equation, and we have the objective variable, which is the second equation, which we have no numbers. We only have variables, right? In this case, in most cases, we'll have 3 variables, and then that's why I have to use the constraint in order to simplify this to only 2 variables, in order to eventually get to the point of getting the derivative. And so when you plug in the W, you get your perimeter, which equals to 2 times the W, which we plug in as 6,000 divided by L plus L. this is the step where you take the derivative. Now that we have one right here, we have one variable here, two variables here. This right here, this is technically a variable, right? When you take the derivative, you get p, the prime of perimeter, equal, this is right here. I simplify this right here, right? Just like as we did in the first example that we did. You know, simplify that, you get 1200 divided by L, which then becomes, you know, just to get rid of the fraction, 1200 times L to the negative 1. Okay? And so we bring this back, right? 12,000, because it is connected with our L, this right here, the 12,000 is a constant. So we keep the 12,000 right here, 12,000. And then you do the derivative of this, which I did not put more room for. Hold on one second. Let me just get rid of this right here. I wish I had an eraser. This would have been so much better, easier, you know. Okay, so right here. So you bring down the negative 1, as I showed you earlier. L to negative 1. Bring this down. This becomes negative 1 times L. Then you subtract 1 from this, and you get negative 2. So then this becomes a negative, because, you know, negative 1 times 12,000 still going to be 12,000. And then you have L to the negative 2, as I showed right here. Negative 1 minus 1, because whenever you do the derivative, you bring down the exponent, then subtract 1 from it, and you get negative 2 in this case. And then plus 1, as I showed. This right here is technically length to the first power. Bring down the 1, get rid of this, this becomes 1, and then you just get 1 like that. This right here is your derivative, which was, I believe, step 5. Actually, no, sorry, step 4, which is the derivative of the perimeter, or our objective, the objective variable equation, right? So remember this, the negative 12,000 L to negative 2 plus 1. Clear that. So this is our P prime, negative 12,000 times L to the negative 2 plus 1. Now you equal it to 0. Boom, boom, boom. L to the negative 2 plus 1. 12,000. L to negative 2 equals to 1, right? And then because this right here, the negative 2, you know, it's a negative, so you bring it under to the denominator. You know, I probably should have done that earlier, but it's fine, you know. As long as you end up realizing you have to do it before you get to certain points, you know, I don't see it as an issue. Do this, right? You have that. Then you multiply the L squared on both sides to bring it to over here, and get it rid of here. And you get 12,000 equals to L squared. Then you take the square root of both sides, and you should get right here, your L should be 109.5445115. That's a really bad 5 at the end. And no problem, no problem. Yeah, it's fine if you head off for a minute and then come back. It's okay. You know, you can always watch it after. I don't have to leave this video. You know what I mean? And so this is our L, which, you know, same thing, square root of 12,000. So remember this. I'm just going to write down quickly as well, just so I don't forget it. 109, 5445115, 12,000, right? Okay. So now we head back. I probably should have written that down too. So now we just gotta do this real quick. Just save some time. Try to reverse. Okay. Oh, no. Back. Okay. So 6,000 square feet. 6,000 square feet equals length width, and then the width equal to 6,000 over L. Boom. Okay, so there we go. This is our W. 6,000 divided by L, and we already know our L. L is equal to square root of 12,000. So then we just equal that in. W equals 6,000 divided by the square root of 12,000. And yes, like I said, you can use the other number, the really large one, the 109. So it was 109.5445115. Yes, you can use this as well. I just find this one easier. Like I said before, saves time. Make sure it saves time. You don't make as many mistakes when you do the math, especially on your calculator. You could have misclicked or something like that, and it's a lot easier to see the mistakes if you misclicked on like this right here than to this. Plus, it's longer too, and it looks weird. You know what I mean? And when you type a lot of stuff on your calculator, it slowly drags everything to the left, and I personally don't like that. So then you do the quick math. 6,000 divided by the square root of 12,000, which you should get for your W equaling to 54.77225575. Boom, bammo, like that. And that should be your answer for your W, and this should be your answer for your L. Okay, I hope that makes sense, right? Makes sense to everyone who's watching. And so now it's asking what are the dimensions of the field, right? What are the dimensions? This is your L, this is your W, these are your dimensions. And but you need to find the perimeter, right? Which, if you remember, we are still on a river, and he doesn't care for this extra length. He just needs the other three. So we have this, your W, this, also W, and this, your W. No, I'm kidding, it's your length. And so you have your 2W plus your L. So you can do however you like. You can put in these really long numbers, or you can put in this and this, you know what I mean? Whatever you find easier, whichever you feel will be more accurate. I personally would prefer doing these ones, the ones which aren't simplified. I just find an easier time doing that, So like your 2W, right? This just becomes 12,000 over 1,200, and you add that to your L, which is the square root of 12,000. So 12,000 divided by the square root of 12,000 plus the square root of 12,000. So in total, right, your perimeter should equal to Oh, frick. Okay. Alright, so your perimeter, based off of all those, right? Don't worry, you can always go back and check again on what we wrote and what we went over. So your perimeter should equal a grand total of 209.089.023. Go back. Feet. That right there is your perimeter. I hope this helps. I didn't really do too much of the complicated stuff just because I myself am not too confident in it, and I don't want to mess anything up by accident. You know how I usually feel. I don't like to mess it up by accident and confuse people. So I did it this way, I hope this way is a bit better, rather than, hold on, let me just go back. Rather than this stuff, just the notes, more notes. I tried for a more, interactive approach, I guess you could say. Like, it's a little bit of notes, but but it's majority of the time we spent here was application. We spent more time applying what I showed for the steps. These steps are here. We did mostly applying those steps. Man, my throat hurts. So, these were the steps for optimization. As you remember, let's say, the pizza, right? We had the area, which was 150. And because we knew the area was 150 square centimeters, that is therefore the constraint. That is what is preventing us from, doing whatever we want. We could put in the most random of numbers, you know what I mean? And yeah, I'm glad that you prefer this approach rather than the much more boring one. But also because you can see the process, but also it's good for myself too, so I can see how I should actually be thinking for these. And so, like I said, for the optimization of the pizza, right? You have your constraint, which was the area. Area equals 150 because we knew it, and then we applied that, and we found for one of the variables, which we chose to find for W, and W equaled 150 divided by L. Then we found the perimeter. The perimeter was I still don't remember this one. It was the objective variable, right? As long as you remember which one's a constraint, the other one's the other one. You know what I mean? So as long as you remember that, I think you should be fine. I don't think they're actually gonna ask you what the objective variable is in the AP test. I doubt they will. Who knows? I don't know. I haven't taken the test before. And so based off of that, right, you have your perimeter, which is the objective variable equation, and you plugged in what we got for W, which for W was 150 divided by L, and we end up getting the perimeter equaling to 2L plus 300 divided by L. And then we did the whole, we prepped it up to make into the derivative. And as a derivative, we got 2 minus 300 times L to the negative 2 power. Then we equal that to 0, right? Here, see? We go back to steps. We equal that to 0 right here, step 5. And we end up solving for x, or in this case, L, the length of the pizza. And with that length, we got 12.24744,871, or the square root of 150. Then we went back, right, to the constraint equation, which is where we found W, which W was 150 divided by L. And we just plugged in L, which was W equals 150 divided by 12.24744,871, or the square root of 150. And in that case, because of how the equation ended up working, W got the same answer, 12.24744,871, or the square root of 150. And then we end up plugging both of them, both variables, the length and the width, back into the desired equation, which is the objective variable equation, or in this case, for the pizza, was the perimeter. And we plugged in, so then we are getting P equals 2 times the square root of 150 plus 2 times the square root of 150, and as a result, the pizza perimeter had total length of 48.989799486 centimeters. I think it's, seems pretty good. And then I showed you a little bit on the one. Then we did the other thing right here with the square, and I asked you guys, what was the thing right here, right? No, actually, we do it. Actually, it was my bad. It was the other way around. You had the square, right? And you had the circle around it. And I asked you guys, because of how they rate the pizzas, the guy wanted to know what was the radius or diameter, right? I think they use diameter, right? 8-inch pizza would be, if you had like a 8-inch pizza, that would be 8 inches long, 8 inches in diameter, I believe. So you find the diameter, which was right here, base, got the base, got the height, a squared plus b squared equals c squared, and that's the hypotenuse, which at the same time is also the diameter of a circle. And that's how you correctly define the length of pizzas that were square, because they don't exactly have a diameter. But if you think of it this way, especially the fact that the pizza that we end up having was a perfect square, you can do this, right? You can do this whole thing because it's going to be even on both sides. Just like if you took the diameter of any circle. Took diameter here, here, here. It's all going to cross through this middle point and go from both sides. It's going to be, the diameter is going to be the same all the way around because it's a, it's a circle. Same thing with a square, Go this way, it's going to be the same as going this way. But also, it's because it's even, just like a circle. And that's just how, it worked. If it was a rectangle, well, I don't want to get into that too much. I'm not 100% sure on this side. I'm 100% sure on this, okay? You could probably still do it, like how TVs do it, but it's not exactly the same way as you'd measure a pizza pie. So, I think that's a wrap. Last slide, right? Notes for optimization. A lot of times, drawing the diagram helps. So in this case, we didn't really do much of the diagrams because I just kind of led the conversation. And plus, it was very basic stuff. Oh, excuse me. Like, here, if you go back, right? You had your pizza pie, a Sicilian pizza. Boom, square. You got area, and you got perimeter, right? Then you had the river. This one, I think, I did a little bit of it. You found that, they wanted the area, and they gave you the perimeter. Then for the final problem, same thing, except this time, they gave the area, and they asked for the perimeter. Cases like this and this, drawing the diameter, drawing the the diagram can help. You know what I mean? Same thing for the second question I asked about the pizza. Drawing this helps, you know what I mean? It helps give you a visual about what's going on in the problem. But also, you can think of other ways to do it. Like, for example, one of the questions we had to do was related to semicircles and rectangles. You have your semicircle. Nope, that's a bad one. You have your semicircle, right? Then you have your rectangle. Because it says that they're connected. Doing this is going to help you a lot. Alright, so you have you got your length. Width, and width. But also, this right here is also the diameter of the semicircle. If you draw it out, you'll see it. This is the semicircle. Boom, full circle. Full circle right here. This right here in the center, that'll be the diameter. Then just divide by 2, and you get the radius. And you can find the area of your semicircle right here, which is pi r squared. I think that's one of the best things that, you know, that I've done. Yes, I did not get to, I wasn't able to fully finish that question because I failed to do the second variable. The second equation. I have the first equation for the area, but didn't have it for the perimeter. That's the reason what happened. So yeah. So don't forget, you need the two equations, right? One has to have a constraint of some sort. The other has to have, you know, you have your whatever it is. It could be perimeter, area, volume, whatever it could be, right? And then you have the two other variables. You find the variable. You find one variable from the constraint equation. Plug it into the other equation. Then you get the derivative of the equation. Find equal to 0. Finds the variable that you use. Then you plug that back into the variable that you dropped while doing the whole constraint thing. Then you get both of them, plug them back into the other equation that you got, and then you get your answer. Yeah, I know it's complicated, you know? I honestly think it is complicated. I haven't mastered it either. I am far from mastering it. But I feel like that doing it this way and breaking down the steps but also doing it visually, I feel like that really helped. The steps right here. You get you find your two equations, you solve for one of them, then you plug it back into the objective variable, find the derivative of the objective variable, equal the derivative to 0, and in doing so you find the variable that you used. Usually it would be, you know, x or whatever your variable is. Then once you find that, you go back to the constraint variable. The constraint equation. Then you solve for your second variable, plug them both back in to the objective variable, and you get your answer. And there you have it. Optimization. I don't think we will have time to go through the limits again, but also because I feel like this right here, I hope it clarified a lot. You know what I mean? So, there you have it. That's a wrap for today. And I hope you guys enjoyed. I hope you guys learned. You know? It was a good 2-hour session on optimization. Though I know some people actually want to see it, though I didn't actually see them, so I hope they actually do come on at some point to watch it, you know what I mean? But also I hope that actually saves. Hold on, let me go to my channel. So I'm on my channel, right? Oh, never mind, it's there. The live stream's there. We are good. So that means yes, it does save. It should save actually. It should be saving. And yeah, I guess I can put in some music again. You know, some music to calm down. What's a good song? I don't know. I haven't. Like, all my music's Chinese. If you guys have any, thank you. If you guys have any questions, you know, just ask. I'll stay on for another. I don't know how long has this live stream been. I'll stay on up until the 2-hour mark. Up until then, you know, we can just chill and listen to music and karaoke, I guess. I don't know. This right here.
I feel something great about.
Alright, so yeah. I'm just gonna put on some music. So here, Sun Nan and Han Hong, Endless Love. This is a good song, I believe. Just you know, we went through optimization. Now we just relax a bit. You know what I mean? Just, you know, breathe, sit, lay back a bit, rest your hands, rest your eyes, close them, drink some water. You know? Ooh, 2 balls of water through this. Not bad, not bad. Anyways, guys, if you want to head out, go for it, you know. And thank you guys, you know, have a good night. And for those who are in my class, good luck tomorrow for the test, you know. I felt like optimization was the hardest thing on the practice packet that we had, so I picked the hardest thing on the packet. You know, I didn't pick the hardest questions because I'm not 100% sure on those, but I hope that the actual examples I gave helped give an idea of what to do for those harder questions. I feel like I could probably, tackle, looking back again, and just tackle them one more time. Alright. So no questions so far, and
This is the best of the best from all over the world. Go big or you go home.
so that is the no one's asked any questions yet, so less than a minute left. The first song at the start, that was Leo Ku's Golden Melody. Hold on, I'll type that in the chat. Yeah, Leo Ku's Golden Melody. There you go. That was the first song that I played at the beginning, and the second one that I played, the one I just played right now, that was Endless Love by Sun Nan and Han Hong. I'll type that in the chat, and I will try to remember to put those also in the description of the video once this is uploaded. I will put up some more songs, There are a lot of other good songs I have on my playlist. If you prefer these kinds, you know, I feel like I prefer them just because they're more calming, and it's a much more different style than what we usually hear nowadays. I feel like that's, you know, I personally just think it's calmer for my mind when I listen to it. So if you guys want me to keep playing those kinds, you know, just let me know. I can, you know, we can keep playing them, you know, one at the start, you know, one or two at the beginning, you know, give people a 10-minute break before we actually begin, and then just chill for another at the end of the last 5 minutes. You know what I mean? I personally think that's a pretty good idea. The other thing I can also do is do Tai Chi Qigong before we actually do the live stream. So like as we wait for people, I'll just put on like a nice soothing song, and then, you know, you just follow the movement. I'll just put up a video of people doing the Tai Chi, and you just follow their movements, and then, you know, for 10 minutes, because I personally think that I've done much better in terms of performance doing those movements before I start studying. I don't know why, but it worked for me. I've done it a couple times already over the break, and, you know, I just did it regularly. The studying, you know, I just came up to my desk, start studying, compared to when I did the Qigong and then started studying. I feel like my performance went up a bit, you know what I mean? I don't think it was significant, but it was something. It's better than, you know, what I had before. So, well, that's a wrap, guys. Anyways, I hope you guys enjoyed, and I'll see you guys later, you know? And I'll see you guys later, guys. 再见.